Alright, so you're told that you have this pattern right here formed by right triangles, and they want you to label all of the legs. So the first thing I would do is label all the right angles. We're assuming they're all right triangles. So that means this is a right angle over here, right? And each intersection here that looks like a right angle will end up being one. Here's one right here. Here's one. Here's one. And it keeps alternating. So you can almost see the right triangles that are appearing here. Now the sides that form each angle are the legs. So this, for example, is a leg, and this is a leg because the angle between them is 90 degrees. If I keep highlighting these, I think you'll see, right, that's a right angle, and so those are the legs, and then here are other legs as well. Now on the other side we have this leg and this one because they form that right angle. And again, we're reusing this leg and that one, that's a right angle. And then we're reusing this leg, and that's also a right angle. So I would just, if this is a question for me, I would just quickly label maybe L for each leg that's given here, because they don't give us letters to denote, right, these pieces. We're just labeling them. Those are our legs. Now on a smaller diagram, what they tell us are the dimensions of these right triangles, and they want us to use the Pythagorean theorem to find the missing side. So if they tell us that this side is 15 inches and that this side is unknown, and they want us to find that side, what do? Well, we're given the hypotenuse, this long side, we're given this side, and the Pythagorean theorem says, hey, if you square each leg and add them up, that equals the hypotenuse squared. So in this kind of a question right here, we know a squared is 225. We don't know b squared, right? That's the unknown. That's the other leg, because a and b represent legs. But we know c squared, well, we can figure it out, right? 39 squared is c squared as the hypotenuse squared. So if we set that up real quick, we can just plug in 39 times 39. That gives us 1,521. Double check. Okay, so that's 1,521. Now to solve for b squared, all we have to do is subtract, right? If a squared plus b squared is c squared, then doesn't it make sense that c squared minus a squared would equal b squared? Right? Just like if 1 plus 2 is 3, then 3 minus 1 is 2. It's that inverse operation. So now we just subtract 1521 minus 225, and that's going to equal b squared. So plugging that in real quick, 1521 minus 225, 1296. So b squared equals 1296. But of course they want to know the length. B squared is the length of the area of a square with side lengths of b. So we take the square root of 1296, and that will equal b. What does that equal? Well, I don't know. It could be a perfect square. Let's do some tests. I know that if I take 20 times 20, what do I get? That's 400. Way too small. And I know it can't be larger than 39 because that is the hypotenuse. Let's try 35 times 35. Getting closer. 35 times 35, very close. Let's try 36. 36, and there we go. So 36 is equal to b. And you will have a square root function on your calculator, but if you forget how to use that, just do some logical guessing, right? You know this length can't be larger than 39. The hypotenuse has to be the longest side, and you know it has to be bigger than 15, right? Why? Because, well, the square root of 1296 has to be larger than the square root of 225. It's a much bigger number. So you know that range automatically. And then try some friendly numbers and build your way up, and you'll quickly reach what the square root is here, or you'll find it's between two whole numbers. All right, thanks.